students, I am Dr. Nimi Singh. Today I bring you a learning module in BSc Forensic Science on behalf of the content writers Dr. GSOD and Miss Tulika Banerjee on a very important unit of forensic ballistics, which is examination of firearm part 2. It is generally thought that a bullet will, after penetrating the glass, experience a large deviation from its normal flight path. Penetration of normal window glass. Very low velocity steel balls will generally cause a very small hole, often no more than 0.1 inches or 2 millimeters in diameter, through the glass, ejecting a large cone of glass from the side opposite the impact. If the cone is not uniform, it can give an indication of the direction from which the shot was fired. For 1.4 inches, that is 5 millimeter plate glass, this can happen at velocities as low as 200 feet per second. For lead air gun pellets, which are soft and readily deformable, a velocity of over 400 feet per second is required to cause the same damage. To penetrate the same glass, the velocity must be increased to at least 500 feet per second. With these readily deformable and relatively slow missiles, it is difficult to estimate their caliber from the damage to the glass. With larger, higher velocity missiles, the diameter of the hole through the glass will only give a rough approximation of the missile caliber and little else. Penetration of laminated glass. When struck by a bullet, laminated glass, that is the glass which consists of two sheets of glass bonded together with a plastic film, will first bulge away from the site of impact. This causes a series of radial cracks. As the glass continues to bulge, concentric cracks are produced, the quantity of which are determined by the energy given up by the bullet to the glass. The quantity of crushed glass round the periphery of the entrance hole is also a function of the energy given up. Easily deformed, low velocity bullets will generally have insufficient velocity to penetrate laminated windscreen or bank teller glass, giving up all their energy on impact. As a result of the transfer of energy, the glass around the impact side, both on the contact and remote glass laminates, will be crushed. Glass will be thrown off the rear face from the remote side of the glass with a considerable force. Crushed glass will also be projected some distance back from the contact side towards the firer. Often the laminate glass will have been stretched beyond its elastic limit and will get torn during the process. The torn plastic laminate and the quantity of glass on the remote side will often give the distinct impression of penetration. Penetration of tempered or toughened glass. The mechanism of penetration is somewhat different as the bullet strikes the surface, got punctured, and the glass shatters into tiny pieces. Radical cracks spread out from the point of impact to the various edges of glass. There is definitely a degree of bulging away from the impact site, realigning the production of peripheral crushing rather than concentric crack rings. Determination of the impact site, caliber of weapon and type is often rendered impossible due to disintegration of the glass around the bullet entry hole. An important point to be specially noted is that tempered glass can take heavy impacts if spread over a large area. A low velocity steel ball will need a sufficiently high point of energy to completely crack a pane of tempered glass. It is unusual to find enough of the entry hole left in block to determine angle of entry due to the disintegration of the tempered glass. Deflection of a bullet by glass. It is generally considered that after penetrating the glass, bullet will experience a large deviation from its normal flight. Glass panes cracked or burst by the action of heat show characteristic long, wavy fractures and can easily be distinguished from the ones broken by the projectiles. In such cases, the curved lines are very feebly developed and generally the glass splinters fall in the direction of the source of the heat. This is a very important point in the investigation of arson cases because the discovery of the glass splinters inside a room may lead the investigators to believe that the window was smashed from outside, which would be incorrect. Sometimes glass panes break without having been exposed to any outside action. The cause of this is that strains may be left on the glass during its manufacture, and these can cause a sudden breakage even without any external stimulus. The improvised firearms, also known as country-made firearms, homemade firearms, pip guns, zip guns, etc. These firearms are made by the ordinary blacksmiths having no particular specification nor are any standard raw materials used. These weapons have very short span of life and most of them are extremely dangerous. The word improvised indicates the nature of firearms. It is more appropriate to refer this class of firearms as improvised firearms rather than dubbing them as country-made firearm, etc. However, the names country-made and improvised are being used in this country frequently. Both the names are being used in this discussion without any distinction. The country-made firearms are improvised by the culprits from the available materials, either personally or with the help of a local blacksmith. The demand for the improvised firearms has increased so much in recent times that they are often manufactured to fire the ammunition which the culprit gets easily, either from the illegal market or from his friends. The simplest improvised firearms which was used in a criminal case was an iron tube in which a 0.22 cartridge could be fixed. The firing was done simply by hammering the base of head of the cartridge case. The advent of the country-made firearms is a result of the stringent controls on the manufacture and sale of ammunition and also of the licensing policy for the firearms. No person in India can get a firearm license and keep a firearm unless his name is cleared by the policy after the verification of his antecedents. Likewise, the ammunition can be purchased only by a licensed holder of firearm, the quantity of which is limited by an insertion in the firearm license itself. The culprits who need arms and ammunitions tap the clandestine market or else they go in for the improvisations. The trade in improvised firearm in India has also been promoted by the fact that the cost of the firearm, especially of handguns, is very high. The normal criminal cannot afford it. Hence, the trade goes on flourishing. The country-made firearms, as already seen, are the non-standard firearms. They are not tested or proved for their fireworthiness. The weapons, therefore, are usually imperfect contrivances which are highly dangerous, even to those who use them. Besides, they are also not amenable to the standard techniques used for evaluating the forensic ballistic problems generated by them. The data pertaining to the standard firearms has no relevance in relation to the improvised firearms. Examination. The evaluation of the evidentiary clues in the improvised firearm follows the usual pattern for correspondence clues in the standard firearms. The parts of a firearm which comes in contact with a cartridge or bullet are firing pin, the breech face, the extractor, the ejector, the chamber and the barrel. They are made up of steel by the process of cutting, hammering, filing, re-aiming and polishing. The tools used in their manufacture are applied at random. The cutting surface of the tools used continues to change because of wear and tear they suffer due to their action on steel. The finished surface of the relevant portions of the firearm is therefore never alike, even when the two surfaces are made with the same set of tools, one after the other. Consequently, all firearms possess an individuality of its own, and this has been established by actual experiments carried out in the initial stages of the development of this science. A long barrel was bored and grooved with the same set of tools. It was then cut into 6 pieces and fitted to 6 firearms. The bullets fired through those 6 barrels were correctly identified in respect of the individual barrels of the 6 firearms. The peculiarities on the surface of a firearm get enhanced with the use of the firearm and also because of wear and tear and accidental damage. When a cartridge is fired, the irregularities of the surface imprint their pattern on the case or the bullet because of close contact under high pressure. These patterns are also called as thumbprint of the firearm and permit their individualization. The cartridge cases and bullets are usually made of comparatively softer metals as compared to the metals used in the manufacturing of a firearm. The marks produced on the surfaces, therefore, do not change substantially for thousands of shots, and the fired ammunition can be identified even when the firearm has been recovered from the crime scene after a long interval. If the firearm is ill-kept, misused or intentionally tampered with, then the peculiarities on the surface may change. The extent of variations will depend upon the changes so made. The fired ammunition may or may not be identifiable. Each case has to be decided by actual experiments. In the murder case, the firearm was buried underground for many months. After careful cleaning, it was possible to identify the fired bullet, in spite of the fact that the firearm had rusted extensively from outside. Sometimes a very old firearm is used in the commission of crime. Due to its extended use over a long period, the barrel of the firearm gets washed and its bore becomes larger. A bullet fired through such a firearm does not house properly in the barrel and hence it is not imprinted with identification marks, that is, the thumbprint of the firearm. Ordinarily, this does not happen during the interval between the commission of the crime and recovery of the firearm. Some criminals use previously fired bullets in cartridges of higher caliber. For example, 0.32 fired bullet is placed in a 12-bore cartridge and fired. This misleads the investigating officer and he searches for a rifled firearm rather than a shotgun. It complicates the investigation. If a cartridge of lower caliber is fired through a firearm of a higher caliber, its bullet does not fit in the barrel and often does not take up identifiable marks. If some marks are discovered on the bullet, they are compared with the fired test bullet of the same caliber as that of the firearm. In some cases, it gives a useful match. Sometimes a loose bullet is marked imperfectly and the test bullet of the right caliber does not give the correct match. In such cases, a lead bullet or a slug specially prepared of slightly larger diameter than the bore is pushed through the barrel. It takes most of the markings from the barrel and provides useful test material. Class and individual marks. The position, the size, the shape and depth of firing pin, breech face, extractor, ejector and chamber marks on a fired cartridge case constitutes class characteristics, while finer details provide the basis for individual characteristics of the firearm. Similarly, the number, width, depth, direction and pitch of the lance and grooves on a fired bullet indicates class characteristics of the firearm, while finer details in the lance and grooves are individual characteristics of the firearm. Class characteristics are, however, common on the ammunition fired from the firearm of the same make and model, but they differ with different makes and different models of the same make. Individual features are so named because they are always different and no two firearms have the same individual characteristics. The class characteristics are useful in quick eliminations. The nature of a firearm and possible make is indicated by the class characteristics. This indication is useful when the firearm is not recovered immediately and there are a number of suspects. Rifle firearm injuries can be identified by deposits from the firing phenomena such as burning, blackening, tattooing and other characteristics present on the target or inside it. All the exit wounds indicate a rifle injury because rifle injuries are characterized by a wound of entry and a wound of exit. All the exit wounds, irrespective of fire range, have the identifying characteristics. No standard shape or size can be attributed to them. They can be circular, oval, slit-like or star-shaped. Any foreign material, including the fired bullet, could be helpful in the identification of a rifled injury. Exit wounds may be identified by the presence of pressed out or pushed out flesh. At times, it may happen that the bullet had sufficient energy to penetrate and enter the body, but not sufficient energy left enough to exit. The presence of bullet fixed in the exit wound identifies it to be a rifled injury. The location of an embedded bullet in a concrete wall will prove it to be a rifled injury and may indicate the direction of its motion. In a similar way, an exit of a bullet through a glass window pane or door would be indicative of the type of injury. If victim's position is correctly known. Rifled injuries can be identified by characteristics, nature of wounds such as through and through wounds which are caused by fast bullets of the rifle firearms, creating an entrance and an exit wound. Ragged wounds, star-shaped wounds, keyhole wound formed by a 0.22 rifle projectile. As already mentioned, the rifled firearm injuries are characterized by the presence of entry and exit wounds. Entry wound. It shows the following features. Bullet hole. The spinning bullet as it burrows into the body causes a circular or oval hole depending on the angle of the entry. The dimensions of the hole are slightly less than the diameter of the bullet due to stretching and recoil of the skin. The margins of the bullet hole are inverted and fibers of the clothing may be driven in. Aberration color. It is caused by the spin and rubbing of the bullet with the skin and is seen around the bullet hole. Dirt or grease color. It is formed by the deposition of grease and other foreign materials, for example dust carried from the barrel by the bullet. Apart from that, other features are also seen depending on the range of fire. Contact range. The circular muzzle imprint is seen due to the branding by the hot barrel along with pink coloration of the edges due to carbon monoxide. Singeing, scorching and tattooing are present in the track but not around the wound. But when there is underlying bone, the shape of the wound is stellate or cruciform due to the rupture of the tissues caused by the explosive gases. Close range 1 to 3 inches. Singeing, scorching, blackening and tattooing are seen around the bullet hole. Near range within 1 yard. This is beyond the range of flame but within the range of powder blast. Hence, singeing and scorching are absent but blackening and tattooing are present. Distant range. It is characterized only by the presence of bullet hole with the aberration and dirt color. Exit wound. Exit wound is larger than the corresponding entrance wound and is characterized by eversion of edges, profuse bleeding and beveling if located in a bone. Singeing, scorching, blackening and tattooing are absent. Track of the bullet. The direction of fire and the relative position of the assailant and victim can be determined from the track of the bullet which connects the entry wound to the exit wound or depending on where the bullet is lodged in the body. The close range effects of flame and powder residue, that is burning, blackening, tattooing, may be seen either on the clothing or on the skin around the wound. Although examination of clothing is of vital importance in determining the range of fired bullet, it is the aberration color caused by the spin of the bullet which identifies it to be a rifled injury. So far as the country-made weapons are concerned, the pattern of the wounds at different range may not conform to that caused by standard firearms. They are non-standard weapons with varying specifications. Examination with individual weapons by conducting experiments is necessary to arrive at any conclusion. There may be a single entrance wound with multiple exit wounds when the bullet disintegrates a bone or fragments itself, and in cases of tandem bullets entering the body at once and separating subsequently. Multiple entrance and exit wounds may occur with a single bullet in rare cases. Shotgun injuries. These are caused due to multiplication of the projectile including shots and wads, shot dispersion with distance, unusual projectiles in rifle cartridges or in muzzle loaders. Here the criteria given below are of very little use. Local knowledge and experience is necessary to interpret these wounds. When a shotgun is fired, the projectile travels in a compact mass. As the range increases, the individual pellets spread out and collectively travel in a cone-like pattern. Their velocity decreases with distance. A rough estimate of the rate of spread is about 1 inch per yard from the muzzle of a full choke gun. For example, the diameter of the pattern or group of average size bird shot hitting the target at 10 yards would be about 10 inches. The target area covered by the shot thus increases with the distance travelled. Meanwhile, the penetrating powder of each pellet decreases. As a general rule, it may be said that the shot enters as a single mass up to a yard. Up to 23 yards, the shot produces an entrance hole with individual pellet holes around the periphery. As the range of the fire increases, the charge of shot begins to spread in a manner discussed above. When a shotgun is fired in contact to near contact with the body, it is likely to show the following features. The shot enters as a mass and the subsequent wound is single, circular, about the size of the muzzle diameter. If the muzzle is pressed firmly, soiling or burning is absent. Muzzle impression may be found. If the muzzle is not pressed firmly or is loosened by recoil, flame gas and soot may escape sideways and soil the adjoining skin. If the clothing interposes between the muzzle and skin, soot will be found on the clothing as well as the skin. The clothing may be singed and there may be burning around the skin wound. The gases will cause laceration of deeper tissues and even fragmentation of bones. The wad is often found in the wound and this may prove an important clue to the type of cartridge used. The wound track and adjacent tissues appears pink due to absorption of carbon monoxide. This appearance is sometimes helpful to disguise entry wound from exit in decomposed bodies. Contact shotgun injuries differ in their appearances depending upon the site, whether it is the head or the relatively non-resistant part, for example chest or abdomen. In the former case, as the gases have restricted space, in spite of grave internal damage, there is generally no exit wound with small shots. Usually, shotgun projectiles do not exit out of the body unless the shotgun is sufficiently large or large caliber buckshot of rifle slugs are used, firing has taken place from a sufficiently close distance, the part of the body hit is not massive, for example, extremities or neck. The victim is a child or a learned adult. The gun is discharged suicidally in the mouth. A close discharge that is between actual contact and about 6 inches is likely to show the following features. Where clothing is present, it will trap most of the soot powder grains and may reduce the flame effect. Scorching of skin, singeing of hair and blackening and tattooing far less with smokeless powder of skin are generally seen. Depending on the angle of firing, the wound is circular or elliptical and the edges must be smooth or crenated depending on the size of the pellets. There are no separate pellet holes. The wound track and adjacent tissues appear pink due to absorption of monoxide. Any felt or cardboard overshot pads or plastic cups from the cartridges will be found in the wound. A mid-range discharge, that is from about 6 inches to 6 feet, that is almost 2 yards, is likely to show the following features. The findings are similar to the close range discharge, except that soot soiling is less and will disappear at over 8 to 16 inches, and with increasing distance, the edge of the wound will be abraded or crenated, especially with larger or short, and the pellet holes will progressively increase around the main wound. A long discharge that is beyond 2 yards is likely to show the following features. There will be no burning or soot beyond about 2 yards. Sparse tattooing may be seen on careful search up to about 3 yards. Infrared photography to detect powder marks, particularly on dark colored clothing, is of help to estimate the range. Wadding injury may be seen up to 5 yards. The wad may cause an independent impact abrasion, a characteristic abrasion or bruise. The charge of shot progressively spreads so that the small apertures due to separation appear around the main wound. With further increase in range, this is followed by more even distribution of pallet injuries with disappearance of the central aperture. At far longer ranges, the shot, depending upon its size and velocity, may not lodge in the body. 0.33 inches and 0.36 inches buckshots are extremely dangerous, even at 100 yards. Reconstruction with respect to accident, suicides, murder and self-defense. In a case a person used a firearm for contact firing at the lower portion of his leg below his knee joint and informed police that his enemy fired at him when he was lying down to sleep, but luckily he survived. Examination of scene of crime and its construction revealed the following facts, which proved that the allegation could not be correct and it's a fake one. The entry wound was situated at such a place where hand of the complainant and firearm could reach easily. The entry wound was at a higher level from the ground, while the exit wound was situated at such a place that the enemy could not reach easily. GSR were found on the higher level wound, that is the entry wound, on a place where right hand of the complainant could reach very conveniently. If a shooter would fire a bullet, he would have done it on the vital part of the body and from a distance, which would not have resulted in GSR like burning of skin, mark of barrel, pink coloration of skin and others, but they were detected at entry wound. The exit wound and entry wound could be identified by GSR particles. The possibility of firing and tracks suggested that it was the work of the complainant and not the accused. GSR particles were detected on the hands of the complainant and were completely absent on the hands of the accused. Garments of the complainant showed presence of GSR, whereas the clothing of the accused did not indicate any GSR. In another case involving trial of a murder, the murderer created circular injuries on his thigh, but no pellets were found on them. He alleged that the pellets could have bounced out of injury holes 2 cm deep with 3 mm diameter after striking the underneath bone. The defense story of self-defense was disbelieved and rejected, as it was impossible to bounce all pellets from one circular hole, resulting in conviction for murder. Suicide had been alleged in another case involving the use of a revolver. The theory of suicide got rejected by an expert on the following facts while reconstructing the crime scene during its examination. The projectile, after coming out of the body, was resting near the muzzle of the firearm, whereas dent made by the bullet was found at a different site. The revolver grasped in cadaveric spasm had a live cartridge, contrary to the fired one. The examination or the reconstruction indicated that suicide theory is definitely wrong, as it constricted material scientific facts and is in fact a case of murder. When one is examining a firearm procured from a scene of crime, certain factors need to be kept in mind. The causes for accidental discharge cannot be overlooked. In addition to it, identification of the caliber can be done by investigating the bullet entry hole. Analysis of ricochet phenomena and bullet penetration through glass is also the important parameters while carrying out the examination of firearms. Moreover, besides studying the make and manufacture of firearm, its class and individual characteristics, it is also required that the various types of injuries are also studied. This certainly helps in inferring the type of firearm that has been used in commission of crime and also helps in reconstruction of scene of crime. Now this is the time for your self-study. If you want to learn more for enhancing your knowledge, you may log on to our website www.cec.nic.in for assignment, MCQs, quizzes, LORs and other materials. Till then, keep studying. Goodbye.